going to present our mini project. Our group is our title is Permanent Magnet Brushless Motor Using ANSYS. So next I'm going to present our group member. This one, my name is Bakar Musa. The second member group is Abdurrahman Abdullah Muhammad Al-Ashmuri. The second member is Muhammad Noor Lukman bin Muhammad Zubair. Next we have an introduction. In the introduction we have 2 points. First one, able to convert the mechanical energy into electrical energy or vice versa. The second one, it can either operate at the motor or generator depending upon the input-output combination. Have parameters that have been calculated. So for the parameter we have 2 iterations. For the first iteration, our value for WTT is we didn't get less than 0.5. That's why we go to the second iteration. For the second iteration, our value for WTT is less than 0.5. That's why the motor is overloading. That's why we choose for the second iteration. Next. For the next, the dimensions of the half rotor and half stator. So this one we use AutoCAD to design, and also we combine half rotor in half stator to get the full design in the AutoCAD. After that it will export to ANSYS software to do the next step for the mini project. That's all about me. I will proceed for the next one.
Assalamu alaikum wa rahmatullah. My name is Abdurrahman Abdullah Muhammad Al-Ashmuri. This is our full model. We have designed it using ANSYS software. We have 24 slots and 10 poles. As you can see that when we divide 24 slots over 10 poles, we get 2.4, which is greater than 1.5. So our project is overlapping. For the winding, as we can see, we did it in another way, which is right and left. The other way is top and down. So there is another way to do it. Next, I'm going to present about the vector line. This is a result of the vector line, which is indicate the most critical part. The most critical part is at the joint of the pole, which is the red one. You can see it's 5. The most value we get is 8.3608 milli, and this value is negative 8.3605 milli. For the flux line for this motor, most of the flux line distribution of the motor is around the green part. There is no any critical part for the flux line in this motor. The highest value was 8.3606 milli, and the lowest was negative 8.3606 milli. For the magnetic field distribution, there is a few places that the motor that is critical shown for the magnetic field distribution. The critical is the red color in the motor or in the field distribution. The highest value of the field or magnetic field distribution was 1.9019, and the lowest was 3.74 times 10 of power of -5. That's all.
My name is Muhammad Al-Ambi Muhammad Zubair. I'm going to present about the result. So this is the VR graph. So our project is 24 slot and 10 pole. As you can see here, we can tell each 10 pole, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, which represent the 10 pole. So for VR graph, this machine is north and south pole about 0.8 for 0.8 positive 0.8 and negative 0.8, where both north pole will have the same value. The magnetic flux produced will travel to the poles of the stator and eventually return back to the poles. Next is BT graph. BT graph has a very low amplitude compared to VR. It can be observed that tangential flux density rate during change of a radial flux from positive region here to the negative region. Okay. Next is clogging top. So for the clogging top, first is clogging electric motor top. As shown is the top due to the contact between rotor is permanent magnet and the stator slot. The top of the clogging varies with the angle of rotation. This top position depend in the number of magnetic pole and the number of teeth on the stator for its periodicity per revolution. Next is back EMF induced voltage. This is my graph, which is the red color is present the induced voltage for A, and the purple one is for the B, and the blue is for C. So the back EMF is generated by the stator's permanent magnet. Second, the back EMF is proportional to the armature rotational speed. And the third is back EMF is the higher the armature's rotation rate, the higher the back EMF release until it is equal to the voltage applied. Okay, next I'm going to present about a winding selection. So from our calculation, we get the coil section is 8. So our coil section is 8. 1, 2, 3, 4, 5, 6 and 7 and 8. So for our project is overlapping, and we didn't have any reverse polarity, and the NCS is 2, which is you can see from here, from coil 1 F1 S1 to the stator 1. So we plus by 2, which is our coil section. We get it the minus, the A1 minus is S3. So as you can see at all of the face A, B and C. This is our winding layout. So like I tell you, our project is overlapping, so the winding is at the left and right side. So for the conclusion, different slot and pole number will have different characteristic. Design of motor with 24 slot and 10 pole is an overlapping, like I tell you before. So and have a medium performance as it is an under design motor. So that's all from us. Thank you very much.